So today we're going to talk about one of my favorite properties and one of the most useful ones, the distributive property. Now, over the years, you've seen the distributive property in action, and we may have called it other things, but it still was the distributive property. So we used it starting in the 4th grade to multiply whole quantities. So 24 times 3 is the problem that we want to do. And it says here to use the area model. Well, the area model is another way to call the distributive property. They're the same thing. The area model is a more visual way to do it. So I want you to always feel like you can use the area model, because when you get to algebra, you will absolutely have to use the area model, not just the distributive property with numbers and expressions. So 24 times 3. What the distributive property says is that you can, when you're multiplying, take your factors and break them up into parts and multiply all the parts. And sometimes that makes multiplication easier to do in your head and easier to do on paper. So what we're going to do is 24 times 3. 24 and 3 are our factors. Now 3 is a factor that's fairly easy to work with. So I'm just going to leave 3 alone. And I'm going to put it over here on the side of the area model. 24, then we can break into parts that are easier to multiply. Now, I know that I could break 24 into 20 plus 4. I could break it into 12 plus 12. However you do it, you get the same result. So let's do it both ways. Okay, so if we made this 20 plus 4, 20 plus 4 is the same as 24. And so 20 plus 4 times 3 is the same as 24 times 3. So all we're going to do is we're going to multiply. This is like a multiplication chart now. We're going to take this times this, and it's going to go here. 20 times 3, and then 4 times 3 is 12. And then we add those two, and we get 72. Okay? That's how you use the area model. So now what if we broke it up differently? What if we said 3 is fine, but we take 24 and make 12 plus 12? Oops, that doesn't look very good, but that is a 12 there. 12, let's try that again. Well, 12 times 3 is 36, and 36 twice is 72. So same result, just broke it up differently. So let's try 47 times 5. Well, I'm pretty comfortable multiplying by 5s, not so much multiplying by 47. So we could do 40 plus 7. And then you multiply 40 times 5 is 200. 7 times 5 is 35. And 200 plus 35 is 235. Fairly simple to do in your head. Now, what if we didn't want to do this using the area model? What would that look like? Well, the same idea, but just written a little differently. So we could do 40 plus 7 broken up, and we're going to put it in parentheses, and then we multiply that by 5. And the 5 can go in front of the parentheses or behind. I like it in the front. So then you would do 40 times 5 is 200, 5 times 7 is 35, and 200 plus 35 is 235. Now I want to show you another way this could have been broken up. If we put the 5 here, we could have also used subtraction to do this. 47 is very close to 50. So we could say 50 minus 3, which is the same as 47, and we do the same process, but this time we would subtract the two partial products, which are the numbers that go in each box. 50 times 5 is 250. 5 times 3 is 15. And if we subtract them, because 50 minus 3 gives us 47, we still get the same result. So I want you to just write these problems down, pause the video, and solve them using the distributive property. Okay, how'd you do? Take a look, and then we'll move on to something else. Okay, so the same strategy can be used with larger numbers. So if you look at the first problem, 53 times 50, multiplying by 50 is really not an issue. So if we take the 53 and break it up, we could still multiply 50, but now it's times 50, plus 3 is what I want to say. Plus 3. So I left the 50 alone. I broke up 53 into 50 plus 3, and now we'll multiply 50 times 50 which is 2,500. And 50 times 3 is 150. And that would be 2,650. So on the next one, 30 times 104, I would leave 30 alone as a factor, but break 104 into 100 plus 4, and then multiply from there. And on this last one, 9 times 199, you could do 199 is 100 plus 90 plus 9, but I would rather say rewrite it as 200 minus 1. So then you would have 9 times the quantity of 200 minus 1. And then you multiply each part and subtract rather than add. So let's take a look at this problem. It says simplify, which means we want to take all those numbers down to a single number. That's what simplify means. And the problem says 8 times 15 minus 8 times 5. Now you might notice that this number and this number both contain a factor of 8. We would call that the greatest common factor. And so we could take that 8 out. And really what that means is we're dividing this quantity by 8 and we're dividing this quantity by 8. So the way you write that is this 8 here becomes a factor of the difference of the other two numbers. So 15 minus 5 is what's left. So if you look, we have 15 here minus 5 here. And so now we could subtract 15 minus 5 to get 10, and that becomes our second factor. And now we have 8 times 10, which is 80. We essentially went from a subtraction problem, or you could think of it as an addition of a negative, a subtraction problem to a multiplication problem, but we have the same result. So this is really the distributive property, but just presented a little differently. So here are 3 problems that are written in that form. Pause the video and give them a try. Okay, so on this first one, 7 is the common factor in the problem. So you factor out the 7, which means it becomes a factor on its own. And what do you have left? 21 plus 9, which is what goes in parentheses. 21 plus 9 is 30. So really we're taking 7 and multiplying it by 30 to get 210. On the second one, you can see that 12 is a common factor. So what's left is 52 minus 62. And so 52 minus 62 is negative 10. 12 times negative 10 is negative 120. And on the third one, the common factor is presented kind of to trick you, but it's 7. And what's left is 16 minus 11, which is 5. 7 times 5 is 35. How'd you do? Okay, so now we are going to apply the distributive property algebraically, which means we're going to introduce variables. Now, a variable is when you use a letter to represent a quantity, and it's an unknown quantity, and it doesn't matter what its value is, because we're just going to apply the properties that we have been talking about. So these are called algebra tiles, and a rectangle, and I think green pretty much usually works. A green rectangle represents the unknown, so I'm calling it X in this case, okay? The squares are integers, so a red represents a negative and a yellow represents a positive. So if we had the expression 2x plus 5, we could represent it algebraically and visually with these tiles. So we would pull 2 of these rectangles because it's 2 x's, and positive 5 would mean we need 5 of these yellow squares. And when you put all that together, this is 2x plus 5, okay? It's just done visually, okay? And we're gonna use that to help us understand the distributive property. All right, so let's look at what this says. This expression says 3 times the quantity of 2x plus 5. Well, we already saw what 2x plus 5 looked like using the algebra tiles. This tells us this 3 means we need to repeat it 3 times. So what I'd like you to do in your notes is to draw 3 times the quantity of 2x plus 5 and then come back. All right, so here was what we pulled on the last slide. This is 2 x's and 5, right? But this says 3 of those. So we're going to repeat that. Oh, that's not what I want to do. That's not what I want to do. Okay, we're going to duplicate this. Let me see if I can make that happen. I'm going to try this again. Hold on one second. Okay. There we go. We've done it twice, and now we've done it 3 times. That's what that expression says. It says we're going to take 2x plus 5 and do it 3 times. So now what we want to do is simplify this. That means we want to count up how many x's we have, and we want to count up how many squares we have. Well, we had 2 x's 3 times, which would give us 6 x's, and we had 5 3 times, which would give us 15. So 6x plus 15 is the number of tiles we have now by doing this multiplication, which is what distributive property is, right? It's all about multiplying. So we can also use the area model to multiply algebraic expressions. So this first one says 4 times the quantity of x plus 4. So really what this is x plus 4 is one of the factors, and it's already broken up. So we could put x plus 4 along the top of our area model because those are the 2 parts of that factor. And then 4 is the factor that is being multiplied by. And so now we would do 4 times x, which is 4 x's. 4 times 4 is 16. So this would simplify to 4x plus 16. So on this other one, 3x plus 1, that's the broken up factor. So we'll put it along the top times 2 along the side. 2 times 3x. If you have 3x doubled, that would give you 6 x's. 2 times 1 is 2. So that would give us 6x plus 2. Now, if you didn't use the area model, you can probably see what the pattern is, and it is just like when we were doing this numerically. Now, let's try these. Let's try them without the area model. Say, if you were multiplying 4 times the quantity of 2x minus 3, you would do 4 times the first part of that factor. 4 times 2x is 8x. And then 4 times negative 3, because that negative sign goes with the 3, would be negative 12. 8x minus 12 is what you get when you multiply 4 times 2x minus 3. What about the second one? It's negative 5 times the quantity of 4x minus 3. You do negative 5 times 4x, which would be negative 20x, and negative 5 times negative 3, which is positive 15. All right, so I want you to try some of these in your notebook on page 74 of your pre-algebra book, number 16 through 29. Please take a picture of your work and upload it to Google Classroom. Good luck.